The Athletic.
Red Bull's slump, McLaren's rise, Alpine's revival and Sauber's disaster. Gary answers your technical questions on F1 2024 in our final episode of the year. Welcome to another edition of the Race F1 Tech Show. I'm Edd Straw and I'm joined by the real star of the show, Gary Anderson. To look back at the 2024 Formula One season in a slightly different way, we've invited questions. So we're going to run through loads of listener questions related to the 2024 season and a few tangential ones, but hopefully it means we're hitting the topics you want us to talk about. But before we get into those, Gary, this has been a great season, hasn't it? So much better than we'd have thought, say, if we were talking 10 months ago.
Yes, it is. I mean, it's great to see competition, I suppose you might call it. It's great to see teams that come from not doing the job they should do to being potential winners or at least big point scorers. So, I mean, that's what we want. We want competition, and I think we want the season to be as long as possible. It is 24 races now, but you don't want the championship to be won halfway through the year. So it's important, I think, that to keep the momentum going there. It does worry me a little bit for 2026 because obviously there's a major change in the regulations again there, and it could be the same again. We just get one team that finds the right concept and heads off in front of everybody else, and it takes 2 or 3 years for everybody to catch up. I hope that doesn't happen. We've seen some impressions of what the FIA think the car will look like. A few bits worry me, and front wing end plates, which we see literally spread across the track quite often, and it's a much more complicated front wing end plate. But we'll have to wait and see what the teams come up with, because that's going to be the real acid test as to what the solutions are to the given set of problems that the new regulations create. But as I say, we've got to a point now where we've had a very competitive season. Although we look at Sauber at the back of the field and think, they didn't do very well. They actually did exceptionally well. They're so close to the front, really. It's such a tight grid, and I would hate to throw that all away again. So let's hope 2026 or the design starts in January of 2025 for the 2026 car. Let's hope it keeps that level of competitiveness and doesn't spread the field out again, for another couple of years, because that would be a disaster.
Yeah, that's going to be the invisible battle of next year, isn't it? The 2026 development, as you say, the aerodynamic testing will start on January the 1st, and most teams are trying to move as much resource over as possible, as soon as possible. So that's one of the little subplots. I guess we'll see a little hint of who's doing what for 26 based on the development rate for each team through 25. But as I said, we've got a huge number of questions. Thanks to everyone who sent them in, and we're going to pile through as many as we possibly can. So the first question comes from Kenny Stoltz. Presumably, windtunnel and CFD time allocations are some parts of the shift away from Red Bull and towards the other top teams. But is there evidence that all the way down the grid, these measures are helping teams? What kind of lag would we expect to see? Red Bull will get more time from January. Will they be able to use that time effectively? So this is a question about the ATR, the handicap in terms of area developments.
Well, the handicap, I think, is a reasonable thing to put in place. It was really sort of started up because the top teams, had endless budget, I suppose you might call it. So they could just brew up stuff in the wind tunnel. They could manufacture it. They could get it on the car. It didn't matter. But now the cost cap sort of limits that to a certain extent. And also the wind tunnel limitation and time does. It's success. It's not necessarily a team name. It's the successful teams that get hit with it, and the not so successful teams gain a little bit of an advantage. I wonder if it needs looked at. Is it enough of a separation? If you take the middle of the pack, or the middle of the constructors' championship, the guys below that get more time, and the guys ahead of that get less time. It is the right thing to do because the guys ahead of that normally are bigger teams. They have more manpower. They have more brain power. They have more equipment, so it's a sort of right thing to do, but nothing is ever right. You could say, well, it's not allowing a top team to sort of do its best. It's limiting. They're handcuffed to a certain extent. I think that can be looked at as wrong or right, but I think intention is good. It's just the application of it and how you end up with allocating that time properly for any team, because for a small team it's usually the limitation of manpower and budget that hurts them. So you can run the wind tunnel for let's say a 5-minute run and gain a lot of information, or you can get the same information over a 15-minute run. And it's down to you to sort of decide what you can get away with. And I think that's one of the reasons now that we're seeing developments that come to these cars not being as successful on the track as they potentially could be, just because you have to restrict your wind tunnel running times. You have to restrict the amount of data you gather, which then hurts your simulation, because the simulator only works on the data you put into it. So it's a circle of events, but it's there. It doesn't do any harm. It should help small teams. It should hurt the big teams. But does it? That's still a question, I suppose.
And it's worth noting that, there's two factors. Firstly, a wind tunnel run for one team isn't equal to a wind tunnel run from another team, because it's about how you use it, your efficiency. The better teams do tend to be more efficient in how they use it, how much they can get out of it, just because the knowledge base is greater. And the other thing is, it is quite a gentle kind of weapon, isn't it? The ATR, for example, Red Bull, they get third place ATR, so that's a drop from first to third. So they go from 70% of the nominal maximum to 80%. So that only means over the first 6 months of next year that they'll get an extra 96 wind tunnel runs and 600 more CFD items. So it's not life-changing, if you like, and it's not meant to be, is it? It's not you win one year and it should be made impossible for you to win in the next one. So the level seems about right, although there are those who suggest you should perhaps look at doing an ATR allocation based more on a curve, on points scored and that kind of thing. Particularly those lower down the order would do that. I'm sure Sauber would rather like aerodynamic testing to be based upon the points scored, as they could probably go back to 2 wind tunnels 24/7 with that.
Yeah, I mean, there's never a right way of doing it. What we've got is something, and what I keep saying about regulations and lots of stuff like that is, once you've got a system in place, that system should be able to be questioned and modified. But that never seems to really happen. It's there. This is what we got. This is what we're going to keep. End of. As you say, the percentages on how you apply it could be looked at, and I'm sure it could be a better solution found. But it isn't like that. It's 96 extra wind tunnel runs. That's massive. But as I say, if one wind tunnel run for a team means you can go through a ride height range of 20 different points of ride height, all with roll, yaw, steering angle. I mean, that's an enormous amount of time. But it's classified as one wind tunnel run. So the amount of data you gather from one wind tunnel run is quite critical, as I say, to your understanding of the car and the simulation of the car. So it depends on how automated you are with it all. If you have to sort of go into the tunnel every time to change the ride height of the car, then you're wasting your time. That's where you have to start. You have to have it all automated. You have to press the button, go, and before you know it, after X amount of time, you've got an enormous amount of data, and then it's down to the manpower to decipher that data and see where the changes have really been as far as the characteristics of the car is concerned.
Next up, we've got a question from Ben. Red Bull had mastered the art of aero platform control for the first 2 years of these regulations. With their suspension with long travel range, the car was smooth over the bumps and able to produce consistent downforce with not so extreme low ride heights. How did they get it so wrong? Suddenly the car becomes disconnected between front and rear, and the drivers said they needed to run it very stiff. What's your take on this? Contrarily, McLaren seems to produce an ever more potent Challenger which rides smooth and is generally better balanced. What do they do, and what can other teams learn from that?
Well, it's typical of finding downforce. You get yourself into a point, and let's just take a simple thing like a wing design. You can run that wing design at a critical level, right to to it's just about ready to separate, airflow separation, and you get very good numbers from it. And when you get to the track, you'll get inconsistency because that wing will be moving. It'll be going, through a different angle range. It won't just sit at that critical angle point. It will be, it'll be inconsistent. And that's really the same in the ground effect cars. We've got ourselves in this little sort of circle. Whereas if you look back to 2022, when these ground effect regulations came in first of all, and we saw the Mercedes zero side pod concept. They felt that route was the perfect way for them to go because they were going for just maximum downforce. And as far as they were concerned, they had more downforce than anybody else in the pit lane. The problem was it just didn't work. So they may have had more downforce for sure, but it was just, again, too critical. And the car, you imagine the car going along a track. It doesn't matter how mirror image that track is, this car still moves. It's moving because of the aerodynamics. It's the forces that are put onto the car aerodynamically. It's moving because of the lateral and longitudinal forces from braking and cornering. And it's moving just because, you're accelerating. So it's, you have to accommodate those platform movements. And I think Red Bull, at the beginning of the regulations, 2022, 2023, were building up to what went into it was a car that was pretty benign. They had a fairly decent understanding from Adrian Newey, from his IndyCar experience, etc., of ground effect cars, that you had to build a car that was fairly benign for ground effect. But as time went past and the other teams started to sort of look like they were getting a little bit more competitive, then you get this trend to say, well, look, I'm finding these X points more downforce if we do this. Should we do it? And you take a couple of those steps and you get away with it. And suddenly then you're finding 10 times that X downforce points, and you just keep on going that route until it's too critical. It's too much for the underfloor. And then the underfloor starts to have airflow separation problems, and the car starts bouncing and you run it stiffer and so on and so forth. So I think that it's a bit of a back off compromise. I think if we take Red Bull, I think it's better to take Mercedes as an example and McLaren, because obviously Mercedes have struggled for a couple of years, and I don't think they've really still got to the point of a car that's consistent. They've still got a car that's got an underfloor design that's a bit too critical to ride height. McLaren have learned that lesson, and I think they've got themselves to a point where they've got a fairly benign underfloor. It's still producing adequate downforce. It won't be as quick as, let's say, the Mercedes on the odd occasion, when you've got a perfectly flat track and the Mercedes gets a bit of the setup right. But it will be, overall it'll be pretty consistent, pretty decent at all sorts of tracks. And I think that's what McLaren showed. So I think it's a fine line between just the numbers of downforce you've got and the consistency of the downforce. And the consistency is what the driver drives. He doesn't like things that got this peak within 1 millimeter ride height and suddenly it's all gone. He doesn't like that, because that's whenever they get a bit of a shock and it bites them in a fast corner and they fly off the road. So from my point of view, consistency of downforce is far more important than the actual total number.
The whole Red Bull versus McLaren thing is a good example, though, of the fact that it's not that Red Bull have got worse. It's all about the relative performance and where you hit your ceilings. So McLaren has just kind of found a way to be a step forward and unlock some more performance. And that's the fascinating thing in Formula One, isn't it? It's always a moving target. Right, let's move on to the next question from Vin Narayan. In broad terms, McLaren seemed stronger towards the end of stints, but weaker off the starting blocks. Were both a function of the same overly gentle tyre treatment? And if so, how might they preserve the former while solving the latter? This is the eternal question, isn't it? Can you ever decouple those two factors?
Well, we had a bit of a insinuation during the season, I think, that McLaren were putting an egg cup full of water in each tyre to try and help it cool down a little bit. I wasn't a big fan of that, because it's so hard to police these sort of things. I'm not saying it couldn't be done. I'm not saying it couldn't achieve the goal, but I don't see it as something that was a priority at the time. I think it is about making sure that you look after the tyres at the beginning, because it's very easy to overdrive these cars. As you see, I mean, the race lap time from qualifying lap time is 6, 7, maybe 8 seconds slower. And that's not all down to the extra 100 kilograms of fuel that's in the car. That's all down to just managing it properly. You're managing the power, you're managing the recharge, you're managing the deployment, you're managing fuel consumption, you're managing you're managing the whole car basically, but also the tyres. So drive within the tyres for that first part of the stint. Whenever we're talking about stints being 20 laps long, let's say, roughly, 18 to 20 laps, taking it a little bit steadier for that first 6 laps means you can be a lot better in the last 12 laps. So it's a matter of weighing up the advantage against the disadvantage. And there's other things as well in the car that I'm sure some teams, we did a piece on fuel tanks a few weeks ago. And it's one of those sort of things. If you manage the fuel where the fuel is in the car, at any point in time, you can manage the weight distribution slightly. And that managing the weight distribution slightly means that you're not overloading one end of the car. So there's lots of little tricks to trying to do that as well. But the main thing is just don't overdrive the tyres. And that means maybe just, backing off from the fact the car's got a little bit of wheel spin. Don't just spin the wheels, just back out of it, because the fact if you spin the wheels, they overheat, the spinning gets worse. Whereas if you can just stay within it, then you're still accelerating at the same rate. You're still doing the same lap time as such, but you're just not abusing the tyres on the way.
I think we also saw McLaren were always quite keen on prioritising that gentler introduction. There was a good example, actually, in Baku. Remember when Piastri did that race-winning pass on Leclerc? He was basically being told to wait because they were thinking purely of the stint management rather than recognising the benefit of the position gained at that moment, which, of course, Oscar Piastri did. So that also plays a part in it. Right, the next question comes from Stuart Coulter. Before the season began, there was much speculation about Red Bull introducing a zero sidepod concept. Unless I missed something, I don't think this ever materialised. So was this simply a huge bluff by Red Bull to distract their rivals, or did they genuinely investigate the concept and decided not to follow through with it?
Well, I never really sort of bought into the fact of the zero sidepod concept because, the reality of a Formula One car is you've got to package the cooling system in something, and you do the best you can, but you have these big pieces of kit that you've got to put somewhere. There may be solutions you could find to minimising the side pod. But again, what we're looking at with a ground effect car is there's two sort of flow fields down the side of the car. One is turning the flow at the front of it, the front of the floor, outwards best possible, using the splitters underneath the floor to turn that flow outwards and set up some horizontal vortices that come off the lower edge of them to go further rearward in the floor into the diffuser. And then the second part is opening up the coke bottle as much as you can to allow flow to go over the top of the floor and out the back of the car down the sides of the diffuser to minimise the flow that's going in underneath the floor as best possible. All of that stuff has to work as one, has to work together. So you actually want a side pod there to turn that flow outwards. The front flow outwards more to act as a large turning vane as such, and that should connect up with the outside of the rear tyre. So that flow that's coming in through the undercut side pod should be getting directed to the outside of the rear tyre, which in turn will mean it get pulled into the low pressure behind the rear tyre. So it acts like a suction, basically pulling that flow out there and pulling it out consistently. And then in the inside of the rear tyre is totally the opposite. It's getting pulled in through to the low pressure behind the rear tyre through the coke bottle, but not underneath the floor because the diffuser's creating a big low pressure area underneath the car. So, you need something in the way of all that. Otherwise, the flow just goes straight through and it doesn't really do its job. You don't get the front of the floor working correctly. You don't get the back of the floor working correctly. You might have a slightly more efficient car, but it just won't create any downforce. So you can't allow the underfloor to have to work on its own. It won't do the job on its own. It needs a lot of help from the overbody flow to make sure the underbody flow is doing what it should do. So I never bought into the zero side pod concept as being a way to go. As I say, maybe it can be done. I don't know. But it's one of those sort of things I never thought Red Bull would go that route either. I mean, the side pods, the inlet is the big thing to minimise. Because any air that goes into that inlet of the radiator it's useless for downforce. So you want to minimise that flow and also get that inlet in an area where it's causing the least damage to any good high efficient airflow that's coming around inside the front of the car.
Yeah, nothing Red Bull said publicly or privately indicated they were going to do anything like that, notwithstanding the fact that there'd be practicality problems because Mercedes had to bend over backwards to make that zero side pod design work, and it compromised the cockpit positioning, it compromised the crash structure positioning, because there's certain things you have to do. There's sort of radius limitations, so it's actually really hard to make that work, and there's sort of a set configuration you have to go for. So it never really added up that Red Bull, not only whether they'd want to, but I don't think it would have been possible to with the architecture they had in the car already.
I think what you're saying there really, Ed, is that the Mercedes put an arm and a leg into it not working, because it never really did work. That it's just one of those sort of situations where they had a concept and they stuck by their philosophy for far too long. I think even to this day they're still doing the same thing. They're not quite believing they got it wrong and buying into the fact we have to do something different here. 2024 has been a bit better, but 2022 and 2023 was definitely questionable as far as that's concerned.
Yeah, you've got to be honest with yourself when it comes to the success or the failure or anything in between of such designs. Right, the next question comes from Alua Damilola Gerald Labirin. I'm still a Mercedes fan. It's been an experience these past few years, to say the least. And as a Mercedes fan, it's been baffling how much of a capricious diva the W15 has been. My question revolves around the W15's preference for cooler temperatures. My initial reaction, once I noticed this, was to think about air density. Cooler air means more dense air. Denser air means more downforce, as aero load is proportional to the density of the fluid. Could this be a case of wrong density assumptions during the design phase of the car? I'm very aware that this is a simplistic diagnosis, so I'd also like to know what other characteristics of cooler temperatures could yield such improved performances from the car.
Well, it could be a simple mistake as far as air density calculations, and it makes a massive difference. But, relatively the numbers are still the same. The big thing that happens between hot and cold is the fact that any surface that is critical to airflow separation problems, it will be more critical when it gets hotter. So you will have more problems the hotter the track surface or the hotter the ambient is. When it gets cooler, the problems will diminish a bit. Now, when it gets cooler, as you say, you'll get more downforce out of the car. So in theory, the car will actually get closer to the ground. So that amount that the problems increase by, it's a bit difficult to sort of quantify because, as I say, with the cooler air, the car will be closer to the ground because it's producing more downforce. The hotter air means the car will be a slightly higher, very, very small amount. But because of the hotter air, thinner air, basically you'll have more airflow separation problems. So it's a bit of a circle of events. But, I don't think you need to be a brain surgeon to realise that because, the temperature goes up and down. You're either wearing a jumper or you're wearing a short-sleeved shirt, a jumper, or a coat. A human being knows what he needs to put on when it's hot or cold. And it's the same with the car. The results from the car will tell you whether it's affected by the heat or the cool, the high density, low density. All of that stuff will come at you, and it's there in black and white in front of you. And it's about you reading it and reacting to it. So I don't buy into the fact that you make a mistake on your air density numbers for your calculations. You can do for sure, but life goes by, races go by, temperatures change, conditions change, competitiveness change, and everything points in a direction at some point in time. And it's about the team of people you have around you to react to that and identify it and then try to find solutions to that problem.
Right, we'll tackle some more questions now. Next up, we've got a question in audio form.
Hello, Edd and Gary. This is Benjamin from Regensburg in Germany. I'm a big fan of your show and I enjoy listening to your interesting discussions. So after the Brazilian Grand Prix, I saw a video on the Williams YouTube channel where they were showing a little bit about the rebuild of Franco Colapinto's crashed car. And it was like in the evening, Tuesday evening, from the moment where the chassis and the scrap bits arrived at the factory. So what I would like to know is about the logistics and the planning of such a job, because they mentioned in the video that they told the guys and girls which would have been assigned to work during the day that they should come in late and work late, so that they were there when the trucks arrived with the parts in the evening. My question is, do the teams usually have a 3-shift system in the workshop, or isn't there enough personnel to cover 3 shifts so that the day shift just has to wait and come in later to be working during the night? And would the teams then typically work 24/7, so during the weekends also? And do they need personnel from the race team to cover as well and work in the workshop when such a rebuild is done?
Well, the question's a very valid one. The big thing we have now is obviously machinery. It's completely different. You're not standing there turning the handles on a milling machine or a lathe. it's all CNC operated. So you program it all, and generally there would be a person there who would probably be managing or running 5 machines as such. So it's not just that you need all your manpower to be there. It depends on what you're trying to address, what you're trying to fix. If it's something like a damaged chassis that's coming back after a crash, then that's a hands-on job. There will be parts that you need to replace in it, like suspension pickup points or whatever, but it will be a hands-on job as far as the repair is concerned. And I think that's what Williams were sort of planning, was the fact that there's no point in you being here watching your machine make stuff, but the guys that need to be there are the guys that's going to cut that bit out of the chassis, sort of prepare it all for a repair job as such, because that's all handwork, and the repair job would all be handwork. So at some point in time, you need people there. Need a lot of people there, 24 hours a day. But as I say, it depends on the job you're doing. And also then the mechanics, putting the car back together again, maybe all the fuel tank and that's had to come out of it because of the accident damage or whatever. So then the assembly of the car, which is the last thing you do before the car runs, you want to make that as compact as you can, because there's no point in the car sitting there for a day before it has to run. It might as well be sitting there for a minute before it has to run. You're looking good. So, the mechanics themselves would have to sort of work long hours or be on a 2 or 3 shift system. So I think to answer the question, it's about going through the complete company, seeing what you're doing, what you need, what the problem is, and then addressing the situation with manpower to suit that. I don't think it's something you do every day of the week. Most of these factories will make bits 24 hours a day, but as I say, you need a skeleton staff just to look after the machines and make sure they're doing everything okay, but not the repair job after an accident. That may require 24 hours a day, mechanical or handwork.
Yeah, and if you go into these factories when they're manufacturing stuff, they've got all the machinery running, and it is amazing on those bits of the shop floor when that stuff's being made, how few people it takes to monitor it and work on it. But that's a great video, the one from Williams. It's well worth a quick watch to get an idea of what a team scrambling to deal with repairs does. Next question comes from Patrick Parisian. Reading Adrian Newey's excellent book, he described how angling the roof of the tunnels downwards towards the side of the car in his March IndyCar days helped to keep flow consistent under the car. And sure enough, the RB18, 19 and 20 did this, while others kept box section tunnels in the throat region. With your previous experience with these cars, was this a solution hiding in plain sight? Also, Indy cars have run tunnels for decades without a lot of the issues that F1 cars have suffered. Is there merit in employing the 50mm step floors as they do as a way of mitigating porpoising, and the need to run stiff suspension to keep the critical floors in their sweet spot?
Well, first of all, let's answer the one about the Indy cars. The downforce that the Indy cars produce is relatively small compared to the downforce that a Formula 1 car produces. And that's because it's, Indy cars is all the best will in the world. It's a one-make formula. If you opened that formula up to the IndyCar teams to make their own underfloors or whatever, you'd start to circle into the same set of problems, or maybe different problems, but very similar to Formula One. There would be problems arise. Whereas with a one-make concept, you have a given floor design. Everybody's got the same problem. Everybody's contributing towards finding a solution to it. And as we see in IndyCars, to be honest, dampers and spring setup, combinations of that, which are variable on Indy cars, can make a massive difference to performance of a team and to the performance of the aerodynamic package. So it's not just about running it stiff, it's about running it correctly and controlling it correctly. Going on to the Indy cars and Adrian's excellent book, I agree with you. It's a very good book. I've read most of it. I haven't read it all, but I've read most of it. Playing with the tunnels is something that is very important. It's not just a box section, and I don't think any of the tunnels nowadays are a box section, or I'll be surprised if they were. There's no point in trying to create all the downforce you can just at the outer edge of the floor, because that's where the lowest pressure will be. That's where the biggest problem with leakage would be. So the thing is, you want to sort of get your pressure trace on the underfloor to be at the maximum on the inboard side of the floor and the minimum on the outboard side of the floor. That way then there's less leakage underneath the outer edge of the floor, so there's less need for you to get the car near the ground. I do agree with you on the 50mm step. It would solve a lot of the problems as far as porpoising is concerned. We started off the 2022 regulations with no step. And I think Edd Straw and I were both at a meeting in Barcelona, I believe it was, when the cars were porpoising quite dramatically. And we had a bit of a meeting with the FIA and various people from FOM about it. And, a suggestion was made at that time to raise the side of the floor a certain amount. I think what they did was wrong, because you have to have enough of a step either to get it away from the floor completely, but the worst thing you can have is it on the floor or near the floor, and just that gap, the difference in that gap from being closed and open is massive. So you've either got to have it a big enough step that it doesn't get near the floor at all, or you have to have no step and let the sides of the car be on the ground, i.e. the sliding skirts that we used to have in yesteryear. So going in between that is difficult, because, as I say, a 10 mil raised section of floor, or maybe even 20 mil raised section of floor, isn't enough. It will still be going through that threshold of working and not working. So it's one of those sort of difficult things to do to get enough of it. The teams didn't want to make it bigger. They themselves said, well, look, let's have the problem. Let's leave the problem with us. But even to this day, we still get drivers complaining about their backs and the bouncing and the hitting the ground and the porpoising, and we can see it on TV. It's still happening. So, the solution that the FIA came up with for raising the floor that little bit wasn't enough to eliminate it. It was enough to maybe help it a little bit. But then the teams pursue trying to make more downforce, so they run the car lower, they run it stiffer again, because you have a small gap, so you want to minimise that gap. So it's a circle of events. The teams are their own worst enemy, because they're just looking for out-and-out downforce.
The next question comes from Bill from Michigan. I'm curious how the scrutineers verify that parts of the car which are required to last multiple races, like engines or gearboxes, are actually the same from race to race, to keep the teams from using new identical parts.
Well, Bill, the FIA do put seals on the critical parts, or the areas that you need to undo to get inside of a critical part. And that's not to say the team can't ask for that seal to be removed, but it would be removed with an FIA scrutineer there to watch, to see that they were only just checking on something that they thought might be a problem, and that nothing was replaced, and the seal will go back on again. So I think as far as that's concerned, they do a reasonable job on sealing up the engine structure so that you can't get inside of it, and sealing up the gearbox structure so you can't get inside it. So I wouldn't really question that part of it. My big thing is more when the cars are in parc fermé, the cars themselves, and you've got one scrutineer per car keeping an eye on things. That's one scrutineer who's part-time, well, not even part-time, he's just voluntary, coming along for the weekend. He's got his clipboard and he's got his jacket on, so he's king of the castle for the day. But, these teams are not stupid. They have solutions to finding everything. So that's the area where I would say maybe we need to look at it again as to how the governance goes as far as not changing the car, not changing the setup is concerned. It's difficult, because some of us want the setup to be changed. Some of us don't want it to be changed. So there's never a right or wrong. But I'm only talking about how it's done now with the policing of it. I think there's room for interpretation as far as what teams can get away with what.
Next question is from Gavin from Perth. At what degree of ignition timing do these engines run at, and why is it so different from, let's say, a road car?
First of all, Gavin, I don't really have a clue. I mean, obviously the engines, the ignition time's set to suit the engine and not to have detonation, or as it's called, knocking, not melt the pistons, basically. And I would say that on most of these now, with the control that we have over the engine, with the turbo, with the electrical power, with the fuel restrictions, the fuel limitation, etc., that the ignition timing is probably active. It's probably controlled by the engine management system, and it would just be measuring for as I say, piston detonation or knocking. So you would have sensors on there that would be giving you the feedback to be able to, when the driver goes full throttle, wants full power, you want to give him maximum power, and I would think that would advance the ignition as best possible to get the best power out of the engine. Otherwise, you'd sort of drop it into the reliability window, because we do see so few engine failures these days, and they are so complicated. But if you take the actual engine itself, detonation is one of the things that during the years we've seen so much of, because it's so easy to just, get knocking, just melt the piston. And we don't see that. So I would imagine that the ignition timing is a fairly active solution reactive to various sensors on the car.
Right, the next question comes from Alexander Law. People are classifying McLaren's constructors' win as a customer win. I get that, but how much is there to be gained or lost in today's F1 engines from the individual arrangements and setup of items such as radiators and even electrical circuitry? Historically, customer teams wouldn't have had as much collaboration with an engine manufacturer as today. I'm curious if there is any benefit outside of improving the aero platform shape compared to previous eras, where you really had to have that work steel to get the best possible engine. To be honest, I feel that Jordan's 1998-1999 efforts with the Mugen Honda package have more credence as a privateer car engine combo. Lower budget works, but not a maximum works budget. Funny how the world works with Aston Martin and Honda linking up in 2026.
Yeah, history's got a habit of repeating itself, really. It is quite funny to see Honda linking up again. It's always difficult to say what is a customer team and what is a works team. And I mean, you could define it quite simply as the people who make their own engine, i.e. Ferrari, Mercedes, obviously, Alpine. Even Alpine aren't really a works team while they've got a Renault engine and they're now going to go to a Mercedes engine. So it's always difficult, as I say, but I think that's where you have to draw the line, is the fact that if you make your own engine, you're a fully fledged works team. You could say Red Bull are knocking on the door there because they're making their own engine, or they're starting to make their own engine. But I think it's the difference between the works team and the privateer is it doesn't exist anymore, to be honest. The engine specification that's supplied to a customer team has to be at the same specification as the ones that you're using, the actual engine itself. So there is no room for, skullduggery, I suppose you might call it, saving up that extra 20 or 30 horsepower for yourself. As far as the packaging of all the bits and pieces is concerned around the car, that is down to the team, any given team. And if you take, the Mercedes teams, which there's more of than anything else, we've got Mercedes, we've got McLaren, you got Williams, and you got Aston Martin at the moment. And all of that packaging is different. So I think each team works closely with the engine manufacturer to optimize their packaging around what they believe in, what they think is the best solution for their aerodynamic package. And it's, as we said earlier, Ed, going back to the Mercedes Zero side pod concept, there's no way they publicly let all their teams know what they were up to with the cooling system of their car way back at the beginning of 2022. They would have kept that a secret as long as possible because they thought that was going to be the magic bullet. So every team has to do its own packaging outside of the engine. There will be the pump outlets, the pump inlets, etc. on the engine, and from there on in, you sort of do what you want to do, really.
Yeah, the regulations have very much closed the gap, haven't they? You've got to have the same engine modes available. You've got to have the same engine spec and everything. So the time of having old spec engines, of not being allowed access to the top engine modes without permission, which was the case in the early days of the hybrid era, that's all gone now. I'd still say there is a tiny advantage in being the works team, by which I'd mean the team that gets to have the most direct input and final say on the configuration of things. But it's gone from making the difference between you being competitive and not competitive at the front, and it's down to it might be a tenth of performance potential maybe now, so it's really closed up. Right, the next question comes from Joe S. The side pods of this generation of F1 car are very different than previous generations, with small slit-style inlets at the shoulder level and deep undercuts to the floor fences. Clearly, this is the best solution as all teams have coalesced around this design, but why does this design work so well? Why does the undercut lead to better aero performance? Is it simply due to the air pressure differential above and below the floor, or are there more complex reasons?
Well, I think we went through that a little bit earlier. First of all, starting with the radiator inlet, you want to try and position that in the position where it's doing the least damage. Now, if you can imagine the airflow coming off the front wing, the wake of that airflow coming off the front wing is trending upwards. It's sort of top of it will be at reasonably high pressure. because it's coming off the top of the wing. The underneath of it will be at reasonably low pressure as it's making the underneath of the wing work and the airflow come through there faster. Then it hits the suspension and you're sort of trying to redirect that flow wake to trim it back again, I suppose you might call it, without affecting the performance of the front wing. And then you're left with, if you look at the car as an aero rake that they mount quite often just behind the front wheel. At that point, you're left with a pressure trace across that area. And the best thing to have is have the radiator opening, the radiator inlet, where that pressure trace is at its maximum, because the inlet, you want pressure on the inlet as best possible. So your aero rake is there to trace that to get a pressure trace across that section through the car. And then as far as the undercut's concerned, you've got airflow that's a bit disturbed because it's done its work on the front wing. It's lost its sort of energy, I suppose you might call it. It's a bit tired. And you want to manage that airflow and not be using it to try to create downforce. So by bringing it over the top of that floor there, you're getting, and it's lost its energy, I suppose you might call it, you're getting less lift on the floor surface. Because if you flow across a surface, it will create a pressure differential. So you got a low pressure air going across the top of the floor. That's not really creating a lot of lift, but that's also helping scavenge the airflow out from underneath that front corner of the floor. And that's where you see the turning vanes and these little vanes that we see from the side of the car all coming outwards. That's to try to pull that airflow that's underneath the floor out of that corner and act like it's I suppose you might call it its own little diffuser. And that gives you some more downforce in that area. But it also means that the airflow that's going to the main diffuser at the back of the car is the airflow that's coming in through the sort of centre of the car, I suppose you might call it. The two biggest turning vanes under the floor are, quite close. They're not that far apart, maybe 50 centimetres or something apart, underneath the driver's knees. And that's the flow that goes in between those two vanes and around the keel of the front of the chassis is the airflow that the diffuser has to work with. It's pulling it from its maximum length, so it's getting the maximum effort from it. But also the fact that the diffuser is limited in size, so you want to pull that airflow. The diffuser can only do so much work, so you want to control the inlet to its optimum so that the diffuser can work efficiently on that amount of airflow. And then while that's happening, you still want to stop the airflow leaking underneath the back part of the sides of the floor in front of the rear tyre. So that's why the Coke bottle is so pronounced, because it allows that flow to come over the top of the floor and come around into the back of the rear tyre, get pulled into there as opposed to getting pulled into the diffuser. So it's a sort of optimising the flow that's coming off the front wing. That's the main thing you're trying to do, because the rest of the car can only work with that. The front wing's the first thing you see, the airflow. It has a wake coming off the back of it, and then the rest of the car has to cope with that. So that's why the radiator ducts, inlet ducts are where they are, why the exit ducts are where they are, why the undercut at the front corner of the side pod is like what it is, and why the Coke bottle is so pronounced. It's all about getting the flow through the car and getting the best energy, high energy flow through into the underflow and the diffuser.
Next question comes from Edd Gaming. As engine development has been restricted in the past few years, has that allowed customer teams to focus on aero development rather than worrying about engine packaging, so resulting in a customer Constructors' Championship win? Will engine development opening up in 26 mean a customer win will become almost impossible again?
I don't think the fact that engine developments have stopped. I think engine developments are contained within the engine manufacturers as opposed to everybody having their own say. Gone are the days whenever we went testing with various different oil scavenge systems to bolt on the engine and try them and see what happened, or various different solutions to engine problems. Now that's nearly all done on the dynos. It's done by the works team, so the customer can focus on the rest of the car, which is important. I mean, again, it's like the old days. You bought a DFV from Cosworth, and it it basically had mountings on the front of it and mountings on the back of it, and you attach the front of it to your chassis and you attach the back of it to your gearbox. We've gone back to that now. The engine mounts are defined, the oil tank recess is defined, the gearbox mounts are defined in the regulations. So it's in a way it's much simpler for the teams, much more complicated, but it's much simpler because the main architecture of the car can be laid out quite well. And it's not such a big deal changing from a Renault engine, as Alpine are going to do, to a Mercedes engine. But it's not easy. But I think the 26, I think we're still going to just have the same thing. The engines will be built by the engine manufacturer. I don't think it's impossible for a privateer team to win the championship in 26. I think you just have to do your job correctly, because whenever we talk about an engine manufacturer, i.e., let's say Mercedes, I'm not far away from Silverstone. Brackley's just down the road, and that's their chassis department. And then you go to Blissworth, and that's where their engine department is. So you've got two completely different factories. And that's the same, whenever you look at it, Mercedes chassis manufacturing in Brackley is, as such, the same as McLaren's chassis manufacturing in Woking. They're both doing the same job. They're both detached from the engine manufacturer. It's not as though they're all under one roof like Ferrari are. So it's possible for a privateer to still win. And it will be in 2026.
Let's get on to part 3 of our questions mega podcast. Edmund Kump says, how does a team like Alpine, who started the season around 10 kilograms too heavy, find weight savings through in-season upgrades? Presumably, they have the same materials at their disposal as they do when the season started, so what can they actually improve? Is it the fabrication process, or are they finding ways to achieve the same safety and performance levels with designs that have less material? It's an interesting case study, isn't it, Gary Alpine? Because that extra weight, a big part of that came from the chassis bulking up they had to do after failing the side load test. But we also had Williams, who had the kind of reverse problem in that they had a monocoque that was way lighter than last year, but everything else was really heavy. So perhaps we just add Williams in as a counterpoint to the different ways you can address weight saving.
Yeah, I mean, I think with today's technology, FE analysis of all the componentry, again, it's the manpower and time you put into all this stuff, and obviously a geometrical design can change the weight of something quite dramatically. What you've got to be careful is that you're not pushed by, let's say, using the word loosely, aerodynamists to achieve something that basically is compromising the structure or the weight, because you carry that extra weight, i.e. 10 kilograms is 3.5 tenths or something on an average circuit. You carry that weight with you all the way, and it takes a lot of extra downforce to overcome that 3.5 kilograms, and that 10 kilograms, sorry, that 3.5 tenths. That 10 kilograms is putting extra load into the tires, for braking, accelerating, and lateral forces. So you've got to have a team of people that just make sure they understand the situation, that you need X amount of downforce before it will overcome X amount of extra weight. And as I say, the extra weight will always be a penalty. So everybody has to understand that. And I think whenever we take Alpine as an example, they had problems with their side impact tests. And whenever you have one set of problems, you don't want two. So you tend to over-engineer it or over-structuralize it, I suppose you might say, make it heavier, basically, so you pass the test next time with flying colours. And then you have to regroup and work backwards from there. And it's never easy to do, but that's what you've got to do. Whereas with Williams, as you say, it was the other way around. They had a light chassis, and all the rest of the stuff got missed in the fact of optimising it. And so you just got to, I think you've got to look at the whole thing as a package, complete package. It's not just the aerodynamics that make the car work. It's not just the chassis itself and all the rest of the stuff you can forgo. You have to look at every detail of every component to get the weight down on the cars. I think the weight the weight of the cars is now far, far too heavy. Now they are bringing it down, hopefully for 2026. I wouldn't be surprised to see that slip a bit. Because there's so much stuff on these cars that it's ridiculous. If the weight was reduced by 50 kilograms, it would put a good challenge into the teams to try and achieve it, because weight will always be important. So if you screw up at the beginning of the year whenever you go to do your crash tests and you have a problem with it because you try to make everything too light, you'll end up with a heavy car because you're trying to recover from that situation. And once you do that, it'll take time through the season to get the weight down in the cars. But Alpine's problem wasn't just the weight of the cars to begin the season with. The car was not a great car mechanically and aerodynamically to begin with, and it took a whole lot of stuff before they got there.
Next question comes from Declan Machin. I've been thinking a lot about Fernando Alonso and his comments on the current Aston Martin car at the Abu Dhabi Grand Prix. This is certainly not the first time in his career he has choice words to say about the car he's driving, but I wonder how much of the car's problems are down to him. My question is it possible for a driver to be bad at developing a car with a team, and ultimately, how much effect does the driver's input in developing a car have on its ultimate pace?
Yeah, it's difficult to say. I think that we've heard Fernando on many occasions in many cars complaining bitterly about the situation. I remember way back, I think it was 2012 in the Ferrari, which wasn't a great car at that point in time, and I remember watching in Barcelona at the test to express his feelings on the car, and then that last little arriving through the right-hander before that chicane at the end of the lap. I remember watching him leaving black marks from from the right-hand corner to the chicane, just by the fact that there was Ferrari engineers out there having a look at the car. So he was expressing his frustration and the fact the car was pretty bad that year to begin with. And again, with McLaren, and then with Aston, obviously. I think it's one of these things, his frustration runs close, I think he's an exceptional driver when he's got the opportunity to be exceptional. But whenever it's just going through the motions, I think he loses his cool a little bit. Is it him that's developing the car that's wrong? He's part of the team. The team consists of two drivers and a whole lot of people. And all together they sit down and they try to get the best solution they can to a given set of problems. So I think he has to take some of the responsibility on his shoulders for sure. But he's not in the design office every day of the week, sort of drumming at them about X, Y, Z. He does his debriefs, he does his job. You've got to believe in your driver. You've got to believe that what he's given you, both as feedback and as far as lap time's concerned, is his best effort. If you find that you don't believe in a driver anymore, then it's time for a change to be made. But I think you've got to believe in your driver. And as I say, Fernando Alonso's part of the team, so I think he has to take some of that responsibility on his shoulders.
I always enjoy his angry radio messages about the car, which he then automatically complains about them being taken out of context in the broadcast. But he knows exactly what he's saying. Next question from Andy. Would you be surprised if any of the teams lower in the standings produce a new concept in the last year of these regs in 2025 to roll the dice?
I think it's very difficult because, again, you've got a bunch of people that are competitive, and the competition starts each side of the garage. They want to be competitive with each other. And I think you see that fight. I think Alpine were a good example of fighting for a better position in the championship. I think Haas and Red Bull too, as I call them. They were all fighting for that sixth place in the championship as best they could. They didn't want to not get that sixth place in the championship. And the ones that didn't were disappointed. So I think it's easy to say, okay, we'll just accept what we've got and we'll get more wind tunnel time, or we'll be better off by doing not such a better job, not such a good job. I think the competitive spirit of the driver and the team, take over. They want to do the best job they can for any given season.
Next up, one from Gabriel White. You've discussed wind tunnel testing a lot, but I wonder, do the teams use the actual full-size car to do all that wind tunnel testing, or is someone on each of the teams assigned to make models? If it's the full-size cars, do they build a third car that they can leave in the wind tunnel, or do they roll the actual cars in and out of the wind tunnel all the time? If they use models, do they 3D print them, or do they cast them or use some other method? I would assume that the models would need to be accurate in order to get meaningful data. This question's great because often there's things we kind of take for granted and don't get into, but it's actually a really good chance to explain, which we've probably never done before, actually what the wind tunnel testing means just in terms of the nuts and bolts.
Yeah, I mean, wind tunnel testing is limited to a 60% model. That's the maximum size you can have. So you're allowed a certain amount of full-scale testing whenever if you relate it to cooling, trying to correlate cooling requirements, etc., etc. But the 99% of wind tunnel testing is on a 60% model or CFD. So you build, you'll have 2, maybe even 3 wind tunnel models, and you will build them all to that scale. Lots of things will be different, and an example is basically the front wing. It's on the cars. It's a carbon fiber with titanium or aluminium inserts in it to support it and mount it, etc., etc. On the wind tunnel model, it could be a machined aluminium wing, or it could be printed, 3D printed, probably 3D printed. And the problems lie in that sort of thing, really, because being able to simulate it correctly, get the same surface finish, get the same detail, is within 100% is quite difficult. And that's why you'll see sort of at a race meeting on a Friday morning, you'll see a driver changing the front wing assembly on the car. And those 2 wing assemblies might be identical, but they just want to make sure that on the car they're identical, that they're given the same sort of forces, etc., etc. But going through the whole car, the rest of it, all the side pods, everything like that, the chassis itself will all be carbon structure. Inside the chassis on the wind tunnel model will be a huge machined aluminium component which will mount the model to the roof of the wind tunnel. All the suspension will be there. As I say, you need to test these cars with roll and yaw. The wheels will sit on the belt. They won't be inboard suspension as such, but all the suspension links will be made identical. Actually, when we say identical, the actual car components are made identical because the wind tunnel starts first and the car comes second. So everything's 60% scale, and it's as best simulated as possible to generate then from those surfaces and those details the final car. The problem, as I say, is that the loads that go into the final car are huge, and the fact that we've saw through time floor supports, floor stays, I suppose you might call it, or wings flexing, etc., etc. Whenever you have a model, you don't want that to be happening because that's changing the results. You want the best data you can from the model. So the first thing you want from a given wind tunnel model is a package that's stiff. You know where all those surfaces are. It's not moving around. Then if you want to get excited about making things move around, you would make, let's say, a rear wing that's theoretically flexed back at X degrees that would be within the FIA load tests. So you test the structural, the fixed wing as such, and then you test a fixed wing at X degrees of deflection, and you look at the differences and say, oh, yeah, now that's where we want to try and get to. So on the real car, then you try and mimic that as best you could. So everything has to be done, as I say, everything starts in a wind tunnel as such, or with CFD, and then you end up getting the car solution from that, and the wind tunnel model, 60%, that's it.
I think it's worth mentioning as well that the model makers are, Formula One's full of unsung heroes on the technical side, but the model makers are really accomplished, aren't they? The detail they have to go into to get these to work. It's not just like you carve out a shape that's the same. It's got to behave in the same way. And a lot of the detail involved in that, as I understand it, is really, really exquisite. A huge amount of effort goes into that and technology.
Yeah, I mean, back in the old days, we would have made parts down the wind tunnel. You'd have got a direction from something. You said, let's extend that front wing flap a little bit. And so you get a bit of aluminium and cut it out and tape it on. And those days are sort of gone. It's a bit sad. But I think, whenever you look at the detail, you see many, many times, you see the Red Bull mechanics putting their helicopter tape or the see-through tape down the body seams. I remember Adrian Newey complaining about the thickness of the decal on the rear wing. He never liked the decal to be on the underside of the rear wing because that thickness of that decal could trip that wing. I mean, it didn't work consistently. Could trip the airflow in that wing. So, again, the 60% model is as critical as that. You need, if you have things that are wrong and it upsets the airflow and sets up little surface vortices, etc., from the body joint lines, or leakage from high pressure underneath the body to low pressure above it, then all the numbers, as they are, irrelevant as such. You're gathering lots and lots of data, but actually it's got a question mark over it. So you have to be as close to the real thing as possible for it to be relevant. I think, you have to push the limits as a model maker to make sure that everything is as perfect as possible.
Next question comes from Max Campesano. What did Alpine do around the US Grand Prix that transformed the car so much? There's no doubt in my mind their Constructors' Championship position was very much flattered by circumstances falling their way. But over the last several races, Gasly especially had the pace to qualify in the top 10 and caused problems for the top teams when he got ahead. While not at the level of McLaren mid last year, it's still a remarkable turnaround. And it certainly was, Gary, that Austin upgrade that just changed everything.
Yeah, it did change everything. I think it's one of those sort of situations where there's a moment when the light bulb goes on, and you think, I've seen this, and this happening, and now, I've got a solution to that problem, or let's find that solution to that problem. It didn't just happen the night before Austin. It happened probably 3 months before that, even when that light bulb.
Well, it really started when David Sanchez, the new technical director, came in, I think, which was that sort of timeline. He could come in and say, right, okay, let's just put a hold on everything. Let's just modify what we're doing. And yeah, exactly as you said, that's what started the process that months later changed everything.
Well, yes. I mean, I think the main thing about putting development parts of the car is about seeing what you're trying to develop. You just you can go blindly forever and just keep firing bits on the car. But if your car's not working correctly, there's just as good a chance of making it worse again as making it better. So it's about sometimes standing back and taking a look at it all and really changing your way of looking at all the data you gather, because these cars are loaded up with lots of sensors. So they go back from each race meeting with massive amounts of data. And to trail through all that and try and find direction is difficult. It's tough, but it's important. Sometimes you have to just stop. A lot of management, I think, in the companies that I've worked with, just like to hear that you're going to find some more points of downforce, kilograms of downforce to make the car go faster. It doesn't necessarily make the car go faster. You might be lucky, and it might make the car go faster, but making the car's characteristics better will make the car go faster, 100% sure. And I think that's probably what David Sanchez was able to do, was to stand back a bit, coming in new, and say, right, I need to understand this, so let's understand this together, and being able to put in his tuppence for us as far as, well, are you sure that's the right way to go? So then they start to develop some stuff. And as I say, it played out in Austin, and even after Austin, there was things came to the car that were positive, were better. They had a new front wing, I think, at the last race of the year, the 2 races before the end of the season, with the slot gap, the leading edge slot gap going all the way across the front of the car. I think that's really vitally important, because as I said earlier, the airflow that's going to the diffuser is the airflow on the centre line of the car. And if you're trying to pull airflow in around the sides of the nose and into the centre line of the car, you're beating it up before you even start. So it hasn't got the same energy. So I think, the stuff I saw them coming with at the end of the season was all logical, decent stuff that, in the end of the day, made the car more consistent. And if the car is consistent, the driver can use his talent to go a bit faster. If the car isn't consistent, it just bites him and he just backs out of it, and suddenly 2 or 3 tenths of a second disappear. Never mind the car being worse or harder to drive. The driver loses enthusiasm for pushing it to the limit as well, because it just keeps biting him and he keeps making mistakes. And whenever a driver keeps making mistakes, very easy for the media, as we know it today, to actually criticise the driver. And it normally comes from just the fact the car isn't consistent enough for the driver to exploit his talent.
Next up, question from Callum Smith. Sauber had the slowest car on average over the 24 season. If the other 9 teams had frozen development from round 1, how far up the grid would Sauber be by the end of the season if their development was allowed to continue?
That's a $1 million question, I suppose. I'd like to know the lottery tickets for the weekend. I think you find that during the season, a lot of talk has been made of the teams finding something like 2 seconds from the start of the season to the end of the season. I think that's rubbish. I've never seen that. And I think if you go testing in, a given track like Bahrain at the beginning of the season, and you go back to Bahrain at the end of the year, and you take into account the conditions, the difference in change in one thing and another, you might end up with half a second if you're really, really lucky. I mean, that's even a lot to find. So I don't think, the thing with Sauber is I don't think that they reacted quickly enough. I think at the end of the season they actually had made the car a little bit better. The last couple of races were reasonable. They never got the end result because of other stuff. But, Sauber were way off at the beginning of the year because of lots of stuff. Their pit stops, their wheel nut problems they had, etc., etc. And it's sort of, you've only got a certain amount of manpower within any team. And if you're fixing problems, your manpower gets eaten up. If you have no problems and you can just devote your brain and your mind focus to developments and your manpower to the developments, then you will step forward. But I don't really see Sauber being saved if the top teams didn't develop during the season. There would have been a bit of a difference, obviously, but that's it's a very hard question to answer because that's the set of circumstances that will never happen. It's all for one and one for all. You start the season, it's up to you to be organised enough to maintain your development rate that you need to do to keep up with the others. It's all relative. Any season's all relative.
Yeah, and sadly, it's unanswerable as well, because even if you were to, say, go back to an early season track, you'd have to have everything identical. And even if you had all the conditions identical, the tyre knowledge would have come on so much that you just get lost in the noise. It's a complicated thing, performance, isn't it? But it is a fascinating hypothetical. Right, question from Oscar Robledo. Having watched the 1,000 brake horsepower monsters of the mid-1980s, how were the Goodyear tyres able to last entire races with the limited downforce levels they had compared to today's cars? Were the Goodyears and Pirellis, when they made appearances, rock hard compared to the compounds used today, or is it something more fundamental, thermal degradation by design notwithstanding?
Yeah, I mean, it's the same old story. You always had to do exactly the same thing. You've always had to look after that black and round thing that connected the car to the ground. I remember, seeing those cars in the 80s coming out of the chicane at the end of the tunnel, leaving black marks to the next corner, just from wheel spin in qualifying. But in the race, you couldn't do that. So, it was always a matter of just looking after what you had. Whenever we had, in the 90s even, had Goodyear qualifying tyres, they struggled to do one lap. If you took the first corner of a given lap, at the maximum performance of the tyre, they'd be dead. The tyres would be dead 3/4 of the way around the lap. So Pirelli's just the same with their tyres nowadays. It's just exactly the same problem. You just have to drive within what you've got. And it's, these cars have knocking on the door of 1,000 horsepower, so there's nothing changes really. It's just a matter of the driver needs to feel the car and optimize the feeling, because when you're, as I say, spinning those wheels because you've got lots of power, you're not going forward. Your acceleration and the coefficient of grip is reduced dramatically, so your acceleration is reduced because you're spinning the wheels. So that's not what a good driver wants to be doing, and it never has been that way. So nothing's changed. It's just the same.
And the final question in this marathon series of listener questions from Steve Camp. Why has F1 now sunk into this cycle of rule changes seemingly every 5 years? Every time now it's about improving the racing, all the while teams claw back nearly all they lost by year 2 or 3 and it's back to square one. Surely more needs to be done in making a bigger set of regs without teams having a say. On top of that, making a larger gap between changes so when the field closes up, we can enjoy it for longer.
Yeah, I do agree with you 100%. I'm not sure about the bigger set of changes. What I think would be a nice thing to do is to, I call it dot the I's and cross the T's every year. Just have a plan a year in advance. This is what we're going to be doing. And, we could take into account some things like, i.e., the sides of the floor is going to go up to the 50 millimetre step again, for example, let's say. Changes that are dramatic enough to mean that you need to scratch your head as a team, but not dramatic enough to change the whole concept. So there's lots and lots of things I think you need to do. I mean, if we had, let's say, the same set of regulations as we have currently now for 2026, but the cars were just going to be 5% or 10%, 5%, let's say, smaller. They're going to be, let's say, shorter, narrower, less overhang at the front, less overhang at the rear, and lighter. But leave the regulation the same. Just they are exactly the same except for the the control numbers of the size of the car and get the weight down. Surely that would be a sort of positive step in the right direction, because we all know these cars are too big, too heavy, too bulky. Surely that would be a thing. I mean, even with the tyres, the same deal. Make them a little bit narrower to suit the situation, because a narrower tyre will be a lighter tyre. A smaller diameter tyre will be a lighter tyre. So at the end of the day, there's logical steps that I can see that over a certain term you should do. But this sort of need to change everything all the time, for me, is a bit of a drama.
The sad thing is with the regs is that we've had this round of regulations, which is all about the cars, and then you've got the power unit changes, and they've had to compromise the cars and everything else to try and make that 50-50 conventional to electric power work. So there's always one overriding thing in any set of rules, isn't it? And there's a bit of push and pull. That's the disappointing thing, because you feel that some of the good work gets undone by different objectives, and so it goes on and on and on.
Yeah, I mean, we take this thing about the MGUH, the heat generator that's connected up to the turbo, and nobody really wants that because road cars don't have it. But there's lots of things road cars don't have that's on Formula One cars, and that's life. But as I say, if we were to leave some stuff alone and just optimise around what we see as the problem, i.e. the cars are too big for the tracks they're racing on, and B, they're too heavy, what's wrong with that? The rest of the regulations could just stay the same, exactly the same, because there's no reason to change it. It's a lot of aggravation. And 99.9% sure the grid split will be bigger at the beginning of 2026 than it is in 2025. So what's the point now? What does that do to competition and racing? I don't really understand. As I say, we need to wait and see what the teams come up with for the 2026 car, because what I've seen at the moment, it's just again an FIA model. But it's interesting to see that they think that there has to be massive change in certain areas, whereas I think dotting the I's and crossing the T's and addressing the problems would be the best solution.
Yeah, most worryingly, those who are doing simulator work on the 26 cars in the Drive and Nuke simulators are still talking about lift and coasting on qualifying laps because of the need to charge. But we won't get into that now. That's a topic that I'm sure we'll talk about a lot when we are back next year. Thanks very much to everybody who sent in questions, not just for this end of year episode, but also throughout the year. We've really enjoyed tackling them, and I know Gary always appreciates listener questions, always been a great proponent of F1 communicating to the fans and getting them inside how things really work. Thanks very much as well to you, Gary. And as I say, we'll be back next year, so join us then for more from Gary.
The Athletic.